So that means we have what we have in it. So I'm just mixing the content of this balloon, balloon A I'll write, and this is balloon B into a balloon C. What we get to see? So that means we have N2, we have H2, we have NH3, right? This is what we have. And the contents of second balloon, N2, D2 and ND3. So that means, as I told you, that this reaction is in equilibrium and this reaction is in equilibrium. That means if the reaction stops at equilibrium, so we will not get to see any kind of change in it. But you know what, as a result we got? After we saw that, we get to see that there are what are the components which were present in this balloon was N2, H2, NH3, N2, D2, ND3, which were the initial components, right, which we mix actually. And we also get to see, you know, instead of that, we get to see the HD also, we get to see NH2D also, we get to see NHD2 as well, and we get to see NH, this I have written. So we get to see so many combinations. So what do you mean? So if you get this HD, if you get NH2D and if you get NHD2, what do you mean by this? This means the reaction still took place because some of this hydrogen has taken the place of this deuterium, replaced this deuterium, and some of the deuterium just replaced that protium. So that means the reaction took place. So that means this is how you are just going to prove the chemical dynamic nature of the equilibrium. Again, I'm repeating for you. If you get the question that how can you explain the dynamic nature of the equilibrium, just explain it with any example as I explained you with the Haber's process. So first of all, write that Haber's process, that N2 plus H2 just unite to form NH3, high temperature pressure condition, catalyst and a catalytic promoter, right? So how you're going to explain? Just take one balloon. Just this balloon is just indicating a closed system, nothing else. You, instead of balloon, you can take a square box as well, right? It is not a hard to find rule that I have taken this balloon and you too have to take a balloon. Just take a closed system, right? I just mean taking a balloon means it is a closed system. It is not going to exchange matter with the surroundings. That is the important criteria. I have told you that when we consider an equilibrium, we need to have a closed container, right? So I took in a balloon, a closed balloon, in which I just added the ingredients N2 and H2, the same high temperature pressure conditions, and what happened? I achieved NH3 with passage of time, right? So when I saw there was no further change in the concentration, so I just concluded that yes, this is the stage of the equilibrium. I left the system undisturbed, right? Then I took another closed system in which I took the same ingredients, only the difference lies that I took deuterium in case of protium in this case. So I just instead of getting ammonia, I got ammonia, but the difference was that ammonia contains the protium hydrogen and this contained the deuterium hydrogen, that is ND3, right? So similarly with passage of time, when I get to see no change in the concentration, I just concluded that yes, it is a state of the equilibrium and I left the system undisturbed, right? So now, as to prove that the reactions are still going on, I took another closed system in which I just mixed those contents of balloon 1 and balloon 2, or balloon A and balloon B in C. Then if the reaction was not taking place, or if you say that at equilibrium nothing happens, you would have not noticed any kind of change. That means after the reaction you must have noticed the same ingredients, that is the N2, H2, NH3, N2, D2 and ND3, right? But what do we get to see after in the mixture of the balloon C? We get to see the new type of combination, that is the HD, NH2D and NHD2. What does it indicate? It indicates the reaction hasn't stopped. The reaction still takes place at equilibrium because this protium just you can say replaced the deuterium, and the deuterium took the places somewhere of the protium as well. So that means the reaction do not stop at equilibrium. It still take place. So this is the important criteria, or the important you can say the aspect of the equilibrium, that it is dynamic in nature.